Hi there, in this video we are going to get to the bottom of the Assistance API in file. We're going to start with a simple case which only uses code interpreter, and then we are going to move on to calling a function, and then we will be calling two functions in parallel, and finally we will be creating an agent with two custom functions with retrieval and code interpreter. We are going to take a look at how we can deal with annotations, file downloads for the file creations, which the code interpreter does. So this is going to really show you everything that you need to know about code interpreter. These files will be available under Everything GPT API crash course that I'm building. Link will be in the description. Let's start with the simple case. So we are doing our imports and setting our API key. The requirements for this project is OpenAI's updated library 1.20 and Pillow for the fourth file. We initialize our client object, OpenAI.client, and everything will take place in this file. We will, so when you create an assistant is created also in your playground. We don't want to keep creating assistants. That's why we are going to grab the assistant ID, write it to a file called assistantid.txt file, so that if this file exists, we are going to retrieve the assistant. Otherwise, we are going to create it. And let's just run this in debug mode and see it step by step, what's going on. So we are creating the file name. After that, we are checking for that file name. If this file name exists, then we are going to retrieve that ID, and then we will be retrieving the agent from OpenAI's cloud. But since we don't have that file, we will be creating it by using client.beta.assistants create. Remember, we have instantiated our client by OpenAI.client right here. So we are going to create an assistant. Assistant can take in a name, a description, instructions. It can take in tools. Here we are specifying only the code interpreter. We are using the latest model. And then we are getting the assistant ID by assistant.id. Here we have the ID of the assistant. Then we are going to write this to file. And now we have written it to file. So next time when we run this, we can simply retrieve this. Now that we have our assistant ID, we are going to retrieve it by calling client.beta.assistants.retrieve with that assistant ID. Now we have our assistant. And we have created our assistant. And if we refresh our playground, we will see that math tutor has been created. We can actually test this in the playground. As you see, it has the code interpreter turned on, and our instructions are here. If you do modify this, next time, I believe, when you retrieve this agent, it will retrieve the modified agent, but it won't reflect in your code the changes which you have made. Okay, and we print assistants retrieved. Now, next thing is we are going to create a thread. We have created an assistant. Now we are going to create a new thread, which will keep track of our message history by calling client.beta.threads.create. And then we will print the thread ID. So now we've created an assistant and a thread, but these are just static objects. They're not doing anything right now. We're going to start them by doing what's called a run. But before we get there, we are going to insert a user message which says, I need to solve this equation. Can you help me? So now that we have the user message, we are going to add this message to the thread. We do that by calling client.beta.threads.messages.create. We insert the thread ID, and then a role as user, and then the user message. Now we have inserted this into this thread, and we print message added to the thread. After that, we are now going to start a run. This run actually is going to take the thread ID and assistant ID and start a series of steps to be executed. Once this run initiates, we need to continually retrieve this run and check on its status. If you go to OpenAI's documentation, the run steps can include requires action if you're doing function calling, in progress, canceling, and it always ends with expired, completed, failed, or canceled. You can take a look at the statuses here. So we need to keep checking until it is completed. That's why we have a while loop, which is going to, we are first going to start our run, and then after that, we are going to retrieve it continually until the status is completed. I'm going to put a breakpoint here. We do start the run by client.beta.threads.runs.create. We give it the thread ID, assistant ID. You can also add additional instructions here. Please address the user respectfully. User requires help with math. You can do that. You can add instructions both in assistant creation and also when you're creating your runs. Just keep that in mind. So we will create this run, and I won't stop it so you can see what's happening. As you see, we are continually checking and printing, waiting for assistant to complete the run. Once this is completed, we will enter this conditional run.status is actually now completed. Now we print run has been completed. We break out of this polling loop, so-called, and now we are going to retrieve the messages because there can be multiple messages in the messages, right? Anyway, but we do need the messages, and we retrieve it by client.beta.threads.messages.list, and we give it the thread ID. When we do that, we have retrieved the current messages we have, just like this. Now we are going to print it. We are going to write it into a JSON file so we can see what's going on. We will be doing this for each file so we can see exactly everything that is taking place. Let's quickly do that. And we do that, by the way, because every object that is returned from OpenAI is a pydantic object, we need to convert it into a writable format like a JSON or a dictionary. That's why, because this is an object, it has a method called model.dump. That's what we do. Now we get the messages.json and we dump it into this file. We're using json.dump with indent. If we now go back and take a look at the messages, we can see that we have a data attribute with a list which contains 2 messages. This is in reverse. The first message is the last message that is returned from the API, and the first message is the message that we have sent. As you see, it is under content. Each message has an ID, and under text.value, this is our message which we have sent, and what we have received from the assistant. Here is the message ID. These are of type text. Content is a list. In this case, contains text and value. Solution to the equation is x equals 1. Now that we've written it to file, we can observe it, right? Let me get rid of that. So now we have messages. We are going to look at messages.data. Let's take a look. See, messages object contains a data attribute, and it contains multiple messages. So we're going to loop over them, and we are going to print the contents. First values, text.value, because it is a content is a list which contains an object. In it, there is a text attribute and a value attribute. And we have printed the assistance message. We're going to do this again and print the user message because that's what comes next. After which time, we are going to retrieve the run steps. And we do that by calling client.beta.threads.runs.steps.list. We give the thread ID and run ID, and we are going to do the same thing and save it to a file so we can observe it, so we can understand what's happening. We do still use the model.dump method. Well, once we retrieve it, here we go. We have retrieved it. If you look at the run steps, it's an object. Now, after this part, our script will stop running, and now we can observe the run steps. Let's take a look at what's in there. So run steps, again, consists, it's an object which has a data attribute. And within this data attribute, and this is in order, is a series of steps. The first step was a type of message creation, right? But the second step is of a tool call, and a type is code interpreter. And this was the input to the code interpreter. This was the output. So we can see that our second step called the code interpreter. This is, you cannot see this in the messages because messages only return the final output or the intermediary messages, possibly if there are any, but you can observe the steps that are taking place within the run steps. Again, both the messages and the run steps adhere to the same schema. It's an object with a data key, which is a list of steps in this case and list of messages in this case. Let's move on to the second file. This is going to be quite a long video, but please bear with me. You will learn everything you need to about Assistance API. Like I said, all these files will be available at Patreon under the Everything GPT API course. Each file has a separate video explanation. I also have vision and speech examples with video explanations. I explain all the basics, function calling, text-to-speech, and vision with the new OpenAI library. And I also have examples for the old library, which includes explanation of parameters, which are still very much so relevant. Let's continue. So in this second file, we are going to give it a function. This is going to work pretty much the same. Let's run it. We do get our imports, put our API key, instantiate our client. This time we are defining a function called getSquare, which is going to receive a function and return the square of it by multiplying it by itself. Here we are defining the custom function name, which is getSquare, which is the name of our function. Again, we are doing the same check. we are going to this time save it to a second enumerated file, assistant id2.txt. We do perform a check to see if this file exists. Because it doesn't exist, we are going to be creating our assistant. We have defined a custom function, and we call client.beta that assistants create. We give it a new name, instructions, model, and this time we have a function definition within the tool list. This is going to have the name get square. Description is get the square of a number. It's going to return a parameter called number, which is the number to be squared, and we do set this number parameter to be required, which is what the model will return if it decides to call this function. Again, we get the assistant's ID, and we write the assistant's ID to a file. If we go here, we can see that next time we run the script, we won't be creating a new assistant. Now, if we go back and check our assistants, we have created a new assistant. We can use it, like I said, and modify it here as well. As you can see, we have a function, custom function called get square. We can see its description here. So this works pretty well. Let's go back to our code. And now we are going to retrieve our assistant. Okay, we have created it and we have retrieved it. We printed. And again, we are going to create a thread. This is the same process that's taking place, user message, and then add the user message. And then we are going to come to the step where we run the thread. When we are running, we are also, again, going to, right after we run it, we are going to enter into a loop and continually retrieve the status of the run. And we are going to check for if the run status gets completed, or we are going to check if the run status requires action. If we go back to the documentation, as we were talking about a little bit earlier, if the model decides to call a function, then it will return requires action, so we can actually check for that. Okay, so I'm going to, I put a breakpoint for both cases. So we are going to run it, and we are waiting for assistant response to be processed. As you see, we entered this elif loop because run.status return requires action. And now we print run requires action, preparing to call the required functions. Now we need to extract whatever those actions are, and we do that by run.required actions that submit tool outputs. And after that, we are going to save it to file, again using the model.dump on it, so we can see its what is being returned. Let's take a look at this real quick alongside of our code files. Okay. So what we got, we did get the required actions, right? And required actions is an object which is a tool calls attribute, which is a list. The reason why this is a list is because there can be multiple actions, there can be multiple function calls, right? This time, this object has a function attribute and a name and arguments. So it wants to call the get square function with the number parameter equaling 5. And so to be able to, so now we need to get the arguments, right? Get the name of the function, call the function, and return the result of the function back to GPT. To do that, we initialize the tool's output empty list. Why are we initializing a list? Because remember that tool calls is a list, and there can be many tools called at the same time. Therefore, there can be many outputs, and we need to populate the list with those outputs. And that's why after initializing our empty list, we are going to loop over the required action that tool calls, because this entire object is the required actions, and it is a tool calls attribute, which is a list. So we want to loop over this list. That's why we're calling that tool calls. We enter it, and action. Remember, now we are in this action. This is the action, and it is a function name attribute. We call that action function name. And now we have retrieved the function name, get square. We're going to load the arguments by JSON.loads, action.function arguments, because this is the action. This is the function. Argument is a JSON. That's why we use JSON load. Now we have our arguments, number 5. After that, we check if the function name matches our custom function name. It does. Now we print calling custom function get square with arguments number 5. Okay. And we do call the function with that argument. Because it's a JSON, we can use the key argument, key value of number, and we now call that function and got the result 25 because it's 5 times 5. After that, now we need to append this result into our tool outputs. We do that by getting the tool call ID, which is action ID. Remember, this was our action. It is an ID, therefore action ID. We add it and we add the output. When we do this, now our tool outputs as one element with a tool call ID and output. This tool call ID corresponds to this. Now we try to loop over it again, but we don't have any more actions. And now we need to submit the function call outputs back to the assistant. And we do that by adding this back to the thread, right? We call client.beta.threads.runs. We are adding it to the runs and to the thread. Submit tool outputs. We give it the thread ID, which we are using, run ID, and the tool outputs list, which we have created. And after which time, function outputs submitted. Now, after this time, we are still going to continue the loop. We are still within this loop until another action is required or it is completed. Function output submitted. We are still within the loop. And now the run.status returned completed because we are continually retrieving it. Now we say run is completed, retrieving assistant response. We break out of this loop. And now we are going to retrieve the messages, calling client.beta.threads messages list by giving it the thread ID. Now, after which time we are going to save it to the messages. Let's do that. And let's observe what's in messages. So now this is our messages object. Remember, this is the last message and this is the first message. Under data, there's a list. This was what the assistant responded with. And this was our message. What is the square of 5? If we look at the content, we get the response of square of 5 is 25. After this, we are going to just go ahead and print it one by one. If we start our terminal, we'll be able to see that we have printed the user and assistant messages. Then we are going to retrieve the run steps by calling beta threads run steps list with thread ID and run ID. And we are going to save it to the run steps by calling the model.dump method and JSON.dump. And this will conclude actually this script. And now if we look at the run steps, we can see clearly that the last step, the first step was a message creation step. And the second step was a tool call of type function, type tool calls. And the function that was called was get square with these arguments. And this was its output. So this is how we can call functions. Now in the third file, we are going to take a look how we can call parallel multiple functions. All these code files will be available at Patreon along with 160 plus other projects. I also regularly host office hours in which you can talk to me. So take a look at it. And if you're curious on what type of projects I work on, you can go to my website, echohive.live, and you can quickly browse it. Take a look at the description of all the videos. You can also search for the type of stuff you're looking for, such as AutoGen. It is an instant search. You can also find the code download links for each project, over 200 projects. And if you're a patron, you'll be able to download the code. Now let's take a look at the third one, which is going to take in two functions. Again, we are defining our API key. We define two functions, get square and get cube. We are going to define a function called create assistant. This time, we are again going to do the same file check. In tools, we are going to define two function definitions, one for get square and one for get cube. Okay, just as we have done. Again, we are going to check for files, write it to file. This particular one consists of many functions. Create thread is responsible for creating the thread. Send messages and run assistant is responsible for creating the message with the user message and starting the run. Poll run status is responsible for continually checking the status. We do, in this case, check for either completed, failed, or canceled, which is a more robust way of doing it. Remember, previously we were only checking for completed, but as a matter of fact, you can fail, cancel, and also get expired. And we are again checking for if we are going to require function calling. And when we do, we are actually going to call our handle required actions, which checks for both functions, and then display final response, which saves, retrieves the thread and messages and saves it to file. And this is our general main loop, which runs this. Let's quickly run this and see what's happening. So this is very similar to the second file. we are initializing, right, our assistant, whatnot. We have created our assistant. We can actually view it here. See, math tutor 3 has been created. We are going to retrieve it as we have done before. We are going to create a thread. And then we are going to add the user message to this thread. And now we have started the loop. Now we are polling, waiting for assistant response. We have entered this conditional because the model required an action. Now we are going to enter the function, which handles our function calling. We print assistant required function calls, and then we retrieve the required actions again, right, by calling run.requiredactions.submit tool outputs, after which time we save them to required actions.json, again, calling the model.dump method on it. We can now take a look at the required actions real quick. Take a look at this. So this is an object, right, again, which has an attribute called tool calls, which is a list of 2 items. The first item is a function call for get square. The second item is a function call for get cube. So now to run these functions, we are going to loop over them like we have done, and then get the name and the arguments for the first function, get square, with the arguments, and then we are checking to match them to our functions. We do, this is the first one is the get square. We then get the output, which is going to be 16, added to the tools output list. Now it makes maybe better sense why we were using a list, because we are first going to append the tool ID and the output of the first one. Then we are going to loop over it again to see the second required action. See, we have handled this. We are looping over this list. We handled this. Now we need to handle the second one. That's why we are going to get the function name, get cube, and the arguments, match it to the function, and then run the function, and then append it to the tool outputs. And once we have done it, if we take a look at tool outputs, now it has 2 items in it, tool call ID and output, tool call ID and output. Now we're going to try to loop over it again, but we are done. Then now we need to submit this message to the thread, to the run, and we do that by client.beta. Let me close this. Client.beta.threads runs submit tool outputs with a thread ID, run ID, and we do input our list here. After which time we are going to continue checking the status. And now we have received the status of completed, and we can break out of this loop and we can return the run. And now we are going to display the final response. We can enter this function, which is going to retrieve the messages list and the run steps, and we are going to save them to file, each of them. And then we are going to print them one by one. Assistant responded with the correct response, and this was our message. Let's take a look at the messages. This was our message, and this is the response. If you look at the run steps, we see that our first action step in the run was message creation. Second step was of tool calls, and then these are the tools that were called, get squared and get cube, and this is it. And this concludes this script. Now let's move on to the best one, which brings everything together. Let's quickly review what's going to happen in this code. We again have our function get square, get cube. These could have been any function you would like to define. And we are going to, again, create an assistant. This time we will be uploading a file. The file we will be uploading is called knowledge.txt. I have just gone ahead and copy and pasted OpenAI's assistant API documentation here, all 3 URLs. This is the knowledge base we are going to use. To be able to use this, we first need to upload the file. So we are going to check if our assistant ID exists. If not, we are going to upload this file. We only need to upload it once. Then we are going to create our assistant with the instruction, with the name retriever, instructions of you answer user questions based on the document provided. You can also do square and cube calculations. Okay. Now the difference is, look, we are also giving it a file IDs parameter, which is a list. So we first upload our file using client.files.create file open. And this is the path to the knowledge.txt. We do use RB, so to read the bytes off of it. And the purpose is assistance. This is the schema you need to use, I believe, to upload files. After that, we do have the file object, which is going to have a file ID, and we input it into this list. Why a list? Because you can upload multiple files, I believe up to 20. After that, we are defining our tools. Again, it's a list Our first tool is the get square tool. Second tool is the get cube function. These could have been anything. Remember that. And our third tool is retrieval. And fourth tool is code interpreter. These are provided by OpenAI. The rest of the situation is the same. We get our assistant ID, write it to file, and retrieve that assistant. So, okay, so that's important. And we are going to do everything the same. We are going to create a thread, retrieve the messages, okay, start a run, and we are going to continually check the status of the run, check if it is completed. We are going to check for function calls. We are going to handle those required function calls as we have done. Now, the really interesting and the complex part of this happens in the display final responses. We will again retrieve the messages and the run steps, and we will save them to file so we can observe them. Okay, and see, in this case, because we have code interpreter, so now what's going to happen is code interpreter can return images, and retriever can return annotations. Sometimes code interpreter can return annotations too, image file, for example. So we need to check for those things. This is just for informational purposes. Okay, this is like if when you run this file one by one, you have to kind of get used to the structure of all these JSON files you're dealing with. But after which time, this is the real crux of the situation. So we are using Pillow here so that we can actually save the image files. But we are already doing it in the beginning, right? We are importing image from Pillow and IO. That's why the requirements are set like this. IO is a standard Python library. But here, what we're going to do is we're going to start with an image counter to 0 because code interpreter can return multiple images. For example, if you were to give it, instead of uploading knowledge.txt, if you were to upload a CSV file with a bunch of data, it can create multiple plots, right? So that's why we need to keep track of the image counter so that we can save each and every one to their appropriate file names, like 1, 2, 3. And then we're going to loop over it. We are going to check all the annotations, all the image files. We're going to display them and save them. This is best seen running. So I'm going to actually remove all the rest of the breakpoints because we've already talked about it, okay? The most important part here was the fact that we are uploading a file. And we are giving the file IDs is a list to the assistant file during the assistant creation, and we are defining our tools, 2 custom functions, retrieval and code interpreter. Rest of the stuff is the same, except this this loop right here. So I'm going to put a breakpoint here, and I'm also going to put a breakpoint here to demonstrate something to you, maybe another one here. Other than that, we are going to create the assistant thread. We are going to enter a loop. So this is an actual chat loop. You can continually interact with this agent. We are going to be able to type our messages in. Let's run this again in debug mode. So remember, we had 2 functions and retriever, which can talk to knowledge.txt, and also we can use code interpreter. So see, we have run this, which means we have uploaded our file. Let's go to our files, cancel out of this. And we have just uploaded knowledge.txt, okay, with the ID that ends with xddl. We'll be able to see what happens here. So I'm going to enter a message like, what is the square of 6 and cube of 8? So we are doing the same thing, right? And we are running, waiting for the assistant's response to be processed. See, submitting function call. We did call the function get square, get cube. We submitted. Now we're coming here, but we also saved the messages. Let's take a look at the messages. We did ask this question and we received the correct answer. Okay, let's look at the run steps. We created a message and then GPT decided to call both of those functions, and we have done that, and we have received the response. Now, here is the interesting part. Let's take a look at it real quick. So messages object, we said, is an object, which is a data attribute, which is a list, right? Currently contains 2 messages. So we are going to loop over that. We're going to check to see if it has content, okay? We are doing that. It does have content. We initialize the citations empty list for the citations with which the retriever can return. And then we go over it one by one. We check to see if it has text. And as you see, it does. See, type text. After that, I'm sorry that it's a bit, because we are running the debugger, this has to appear here. Maybe I'll move it like this. See, and what we're trying to do is now retrieve. So look at this object. So we have this data list, and then we have this content list. So this content list can contain many things. It can contain text, or it can contain image files. And also there's annotations, and annotations can contain things in them as well. Okay, so we're trying to, what this loop does is it tries to go through over each and every one and retrieve if there is annotations, if there's file citations, and if there's any image files. Okay, so let me just skip over this real quick because we don't have any of that. As you can see, annotations are empty, and our only value is a text value. So let's try to demonstrate image situation. So I can say something like plot these numbers on a chart, and I can give it 2, 5, 7, 13, 56, and this. Okay, right? Let's see that. So we asked it to plot these numbers on a chart. Let's close this because we're gonna get a new messages object. So currently the assistant is working exactly as it should. We are waiting for its response. Okay, and now we have gotten our response, and now we have our messages object. Let's take a look at it. See, this messages is now growing. As you see, our first question is here, answer is here. Our second plot these questions is here. And if you look at the final response, see the content list has grown now. It has 2 objects in it. One of them includes image underscore file with a file ID. It's a type of image file. And it also has text response. Here's a chart plotting these numbers. And this corresponds to that chart that it's talking about, right? So now we need to loop over and figure out what's the image file, what is the ID. We need to retrieve that using pillow displayed and save it to file, okay? We also want to display the text message as well. If you look at the run steps, see after the message creation, we can see that it called a tool. The tool it called was code interpreter with this Python script, and it created an image output, okay? And that this image file, DL3, is also apparent right here. So we need to capture that somehow. This is what this loop is going to do now. We'll be able to see it better, but we are using the loop over the messages. So let's see what happens. We enter the messages object, right? And we enter the list under the data attribute. That's what we're doing here for message and messages.data. Okay. And we check, does message have content? Yes, it does. We go in and we initialize a citation. And then we check for the content part in message.content. So this is one part, right? And this is the second part. And then we check. Let me go back up. Is content part type text? It's not. So not the first one. The first one is image file. That's why we skipped this and we went down and we are doing something which is not that important currently. And then now we are checking if it's an image file. As a matter of fact, it is. As you see, content part, right? This is the part. Dot type equals image file. Then we get its ID, content part, image file, file ID, because content part has an image file and a file ID. We grab that. And now we are going to retrieve it using client.files with raw responses, retrieve content with that ID dot content. So this was told to me by a Discord member, Fernworks. I'd like to thank him for it. If you'd like to talk about large language models, please do join our Discord. Link will be in the description. I did improve on the code that he had provided, and I'll explain in what way. First of all, we are using the pillow. In any case, so we are retrieving the bytes. See, now we have image data. As you can see, it is a list of bunch of strings. Now we are going to use what we have imported from pillow. We have imported image, and we are using IO right here. We are image.open, IO.bytes, image data, which we have retrieved. Now we have our image, and we show our image, just like this. This is the plot. And after that, we are going to use the image to save it. And we have saved our image. We can also view it, and it's numbered as 0. Okay. And now we try to loop over again. Why? Because now we are going to take a look at the next one. The second part, is it text? Yes, it is. So we enter it and we extract the value, but there is no annotation or anything like that. So we skip that part. increment the image counter, try to see if there's any other message. Yes, there is, right? The previous messages. So we're going to quickly skip over them. We keep adding it to our updated messages list and we print them. As you can see, the first one was an image file. The second one is the text, which says here is the chart. And the rest of it is our previous messages because we're continually adding to it, right? So that's how we handle images. Now, the part that I improved on it is that if you take a look at the messages object, we see that the image file attribute had been returned under content. But what I've noticed running this again and again is that sometimes the code interpreter will return the image file under annotations. So when that happens, we might miss it. And we are checking for if, for example, file citation exists. We are also doing another check to see if file path exists, because it can under annotations. If it does, we apply the same logic here, okay? And we get the file ID, retrieve the image from the cloud, show it and save it. So that's the difference. Okay, we are performing an image file check in both places. Why does this happen? I'm not sure, but sometimes the image file will appear, the image file information will appear under content and sometimes will appear under annotations. So, but what is the real use for annotations? Let's talk about that now, which happens when you do retrieval. To demonstrate what happens with retrieval, let's ask a question. I'm going to ask, what is Assistance API? Use the document to answer. Let's put a question mark here. I do say this because sometimes it doesn't use the retriever. People have said perhaps that you should enhance the instructions more to entice it to use the retriever. In any case, we are going to say this, and we are running. We are going to wait until what happens. We will be able to observe the steps once it's done to see if it had actually called the retriever. Okay, so the responses have arrived. Let's take a look at the run steps, and it has called it. Remember, first message is step is message creation, and second step is a tool call retrieval. And here's the ID. Now, if you take a look at the messages, you will see that again, we have the same object, but instead now content includes annotations, right? Such as the start index and end index it includes a quote. It also includes a file. This file ID, xddl, is the original file which we have uploaded. If you click on it, you can see that's xddl exactly. So this file ID corresponds to the knowledge file, right? The file which we have uploaded. The quote is kind of like I believe it's just a small representation of the chunks which was used. That's my interpretation. We have the indexes and we have this text thing right here. Okay, this is a type of file citation. Okay, right. And this whole thing is type text. So this whole object is of type text, but in it, under text is another attribute called annotations, which include all this information. And sometimes, as I was saying, code interpreter will return the image file in this. Maybe we can do another run just to try to demonstrate if you get lucky. But the most important thing is that this is the text response. This is the answer. The Assistance API is a feature that allows you, right? So this is our answer. And at the end of it, we have these characters. These characters exactly correspond to this text. So what we are going to do within this loop is actually loop over, okay, find this, match it to this, and replace it with the file ID, and actually also put an index number on it. So this is how a citation works, right? So it's going to, instead of these unrecognizable numbers, it's going to say 0, and then it's going to put in the quote there, and it's going to say this is from the file, this one, which corresponds to the knowledge.txt. So let's see this in action. Let's actually pull this message file right here. Maybe I'll zoom out. I know it will be difficult to see when zoomed out, but I think it will be more understandable. So again, we are going to enter this message object's data attribute because that is the list. So now we have entered. We are checking if it has content. Yes, it does. And we have initialized the citations to empty list. So now we are looking at the content. We are checking if it is type text. Yes, it is. So we enter here, and then we now say content part text, right? We enter this, and we enter annotations list. And then we get the text value, text.value. We grab this, Okay, and if we compare Assistance API is a feature, so we've gotten it. So now we're going to look into annotations. Annotations is a list, and it can include many things, right? Many chunks, for example, or many different, it can retrieve from many different files. Therefore, we need to enumerate over it. The reason we enumerate is because we also want an index. So we're going to loop over this annotations. Our index is going to be 0 at first, and this is the annotation object, because this is an object. Okay, now we are going to take a look at the text value, which we have extracted, which is this. And we are going to replace the annotation.text, because annotation.text is this, right? We have retrieved this annotation object, and it is a text value, which is this. So we want to find this in the text and replace it with the index, which is 0. And now we have done that. And then we see if the attribute, if the annotation has a attribute file citation, which it has, then we enter here. And then we are going to retrieve the file, okay, with using this file ID. And now that we have retrieved it, we have its name, right, knowledge.txt. And then we are going to append to the citations the name of the file, which now we have done that. If we actually look at the citations, we have appended the index, the quote, okay, which is here, and at the end of it, let me try to do this again. And at the end of it, we insert from knowledge.txt. So what this entire loop does is it just gets all this information and puts it in a more organized way. And we try to loop over it again, but we are done. So now we have our citations. And we have our text value. All we're going to do is we're going to add it to the end of it. Okay. And that's it. We're done. Updated messages list, right? We're going to add all the messages because we are still going over from the old messages as well. And then at the end, we printed it. And if you take a look, assistant responded with this is the message. But at the end, see, we have this source thing. It actually converted into that. Okay, so all this is to do this. Okay, and let's try to demonstrate the plotting. Let's do the plot these numbers again. So we can find this message here, right? Because these messages include all our messages. Oh, it doesn't, because I actually had to restart the script because I accidentally turn it off. Plot these numbers. Let's give it some numbers. Okay, so let's just run it. I just want to demonstrate to see if we can hit this condition, just so you see why it is important. We may or may not, but let's see. Okay, we are entering it, and no, see, we are still getting it as a image file object. So let me run this again. And okay, I've ran it several times and haven't hit this condition, but suffice it to say, I have hit it before. It's a rare case, but we are handling it for it here. And this is it. And I hope you enjoy this. I know this was a long one and it's a bit arduous, straining, but I hope if you go over this video a few times, I believe you will understand the Assistance API. This is really all there is to it currently, unless OpenAI updates it. Let me know what you think of it. And hoping to see you in the next video. Remember that these files will be available in Everything GPT API course. Link will be in the description. Thank you very much. Take care.